Hey everybody, thank you so much for listening to the Well-Read Christian podcast. And I decided at the last minute to split this episode up into two different parts, because there's a lot of information here in what is now going to be part one. And I really wanted to make sure that you can absorb as much of the information as you're interested in. And the 55-minute episode just seemed very overwhelming. So here in part one, we're going to do three things. First, we're going to introduce the fine-tuning argument and where it's at and where it's been. And after that, we're going to present you with the actual cutting-edge research that's going on in the fields of physics and cosmology and has been for the past 50 years. And I'm going to not shy away from explaining the actual science. And I'm going to explain how the scientific discoveries in the 20th and the 21st centuries have shown that the universe really does appear to be finely tuned. And that is extremely unlikely to support advanced life unless it was designed by an intelligent designer. And so I want to invite you to stick with it if you find yourself overwhelmed halfway through this episode. I'm going to go over the evidence with enough detail that if you were sitting up and taking notes, you'd be able to walk away with a pretty impressive overview of what the experts are talking about and why it's important. But if you do find yourself overwhelmed and would rather sit back and just enjoy the show, be encouraged, because the third thing that I'm going to do in this episode, the last perhaps 10 minutes or so, is summarize what the experts have said about these discoveries and the importance of these discoveries and what these discoveries likely mean. And so I wanted to make sure that I give you the actual science and information. That way, one, you can be educated if you so prefer, and two, those quotes at the end are not going to feel very impactful if you don't actually know why the experts are saying the things that they're saying. And then next episode, in part two, we're going to talk about the conclusions that scientists and philosophers have drawn, given the evidence that the universe appears finely tuned. And we're going to explore the arguments that they use in order to try to support their position, and in some cases, why those are really ridiculous arguments. But before we can talk about explaining why the universe is finely tuned, we first have to establish that it actually is. And so even though the science is peer-reviewed and mainstream, and has been for decades, it's still a very important foundation to establish. It's important to the argument, and it's important for you to be aware of. So without further ado, let's get to it, and once again, thank you so much for listening. Thank you for listening to the Well-Read Christian podcast. I'm Mark Stanley, your host, and today we are looking at one of the most popular and compelling arguments for the existence of God, the fine-tuning argument. The fine-tuning argument is under the umbrella of a teleological argument for God, and the teleological argument is one which observes apparent design in the universe and moves to infer a designer. This kind of argument dates as far back as the ancient Greeks, but its modern form can trace its roots to 1802, when William Paley, a Christian philosopher and clergyman, published a work called Natural Theology, or Evidences of the Existence and Attributes of the Deity. The argument was powerful and popular until Darwin's theory of evolution posited that not all things which appear designed really are. But discoveries in physics and biology have brought the teleological argument back into the forefront of science and philosophy. One of the most persuasive and engaging contemporary teleological arguments focuses on the fine-tuning of the laws of physics and the history of the universe itself. While teleological arguments based on biological complexity, or the information matrix of DNA, are still faced with cultural bias from creation versus evolution controversies, the fields of cosmology and physics have not been similarly marred. Of the three contemporary teleological arguments, the fine-tuning argument in physics and cosmology has made tremendous ground in the academy, as we will discover, with antagonists being forced to postulate ever more complex, metaphysical, rather than scientific, rebuttals. But before we begin our survey of the fine-tuning argument, I would like to ask that if you have benefited from the podcast or believe in our mission, please consider making a tax-deductible donation to support our work on our website, wellreadchristian.com. There you will also find interesting quotes, sources, articles, and more available free of charge. These are tough times for all of us, and if your contribution would cause any amount of financial pressure, please do not even consider it. But for those who are willing and able to give, it is because of your gift that the podcast can continue and even grow. So thank you. The teleological argument we are going to examine is called the cosmological fine-tuning argument. or sometimes the cosmological anthropic fine-tuning argument. This argument examines the laws of physics and cosmology and recognizes that there are an unfathomable amount of ways in which the universe should have become entirely life-prohibiting, and asks for the best explanation of this miracle, that the universe is, in fact, life-permitting. The argument essentially makes two steps. The first step is to argue that the universe, as we see it, is, in fact, finely tuned for the existence of life. The definition of fine-tuning can be hard to pin down, but a simple definition is that a thing is finely tuned if it conforms to precise specifications, without which a given result would be impossible. In our case, the given result is the possibility of advanced life. Once it is established that our universe does exhibit signs of being perfectly constructed for advanced life, even though it would have been extremely more probable for the Big Bang to produce a lifeless universe, the second step is to ask what best explains why the universe is finely tuned. Once you ask why the universe is finely tuned, you basically have three possible explanations. Number one, intelligent design. Number two, pure, raw, unadulterated chance. Or number three, physical necessity. And boy, is it amazing watching some thinkers speculate even more complicated, untestable, really philosophically nonsensical ideas, such as multiverses or universe-creating machines, to avoid the obvious conclusion of an intelligent mind. Some will even resort to arguing that we are in a simulated reality in order to avoid the obvious conclusion to the teleological argument. Of course, that's ridiculous because even simulations require an intelligence to design and run. But first, let's talk about the facts and determine that the universe is, in fact, finely tuned. The evidence for the fine-tuning of the universe is so expansive and detailed that I don't even have to refer to Christian scientists to make my case. Paul Davies is a 4-time award-winning theoretical physicist who wrote a book called The Accidental Universe, which details several astounding miracles which contribute to the universe being capable of producing complex matter, gravity, atoms, and the like. He has also written a groundbreaking work called Just 6 Numbers, which outlines the most powerful examples of cosmic fine-tuning. John Barrow and Frank Tipler are both physicists and have done incredible work in the fields of cosmology. Together, they have written many things about the fine-tuning of the universe, including the famous work which they wrote together called The Anthropic Cosmological Principle. In it, they compiled an impressive list of unlikely factors which resulted in a life-sustaining universe. The final scientist whose work we are indebted to is Michael Rees, the president of the Royal Society in London from 2005 to 2010. I couldn't read all the awards he has in one breath. Rees is an astronomer, an astrophysicist, has written over 500 articles, and was one of the foundational researchers who discovered the cosmic microwave background radiation, which was yet another defining proof of the Big Bang, one of the most important discoveries of the 20th century. He also contributed to groundbreaking discoveries such as galaxy clustering and formation and the distribution of quasars, which finally was the straw that broke the camel's back in the steady-state theory of cosmology. Rees is an avowed atheist, even refusing to accept the Templeton Award because of its religious origin and purpose. He has been cited, however, criticizing fellow atheists for being closed-minded and militant towards religion. These 4 men offer the most decorated and detailed descriptions of the fine-tuning of the universe, and I'm going to give you some of the most powerful claims to fine-tuning from their work. There are obviously dozens more physicists who have written about the fine-tuning of the cosmos, but I have chosen these 4 physicists because of their stature, their non-religious backgrounds, and because of their prominence in the field of fine-tuning. I cite their names for you not to make an argument from authority, but to try and show that this isn't some hokey religious pseudoscience. This is mainstream, peer-reviewed, widely accepted research that you don't get to dismiss just because you don't like where the evidence is pointing. So buckle up, things are about to get deep. The first evidence for fine-tuning that we have to talk about is the cosmological constant, which is a mathematical constant in Einstein's equation for special relativity. The cosmological constant, often referred to as dark energy in our observations, accounts for the repulsive force that causes space to expand and gravity to bend. This force, which expands the universe continually and at an even faster and faster rate as time goes on, ensures that the universe will never contract back into itself. When Einstein was originally doing his calculations, he realized that his own theory postulated a beginning of the universe, and thus, perhaps, a God who created a beginning of the universe. Einstein did not like that theory, and so he plugged in the cosmological constant a number which would allow for the universe to be expanding and contracting kind of at the same time in order to allow a steady state theory of the universe to be reasonable on his theory. But when Edwin Hubble discovered the red shift in the Hubble telescope that he designed, and Einstein looked through it, he realized, no, the universe really is in fact expanding, and his calculations really are correct. He went on to call the cosmological constant the biggest blunder of his academic career, and the reason is because he fudged the number originally in order to try to favor his theory. So now that the cosmological constant is really secure science, it turns out to be a real problem for atheistic cosmologists, and the reason is because the cosmological constant has to be incredibly fine-tuned, because in the beginning of the universe, if it was even a tiniest bit stronger, the universe would have expanded too quickly at the Big Bang, which would have resulted in every individual particle soaring into the infinite beyond without consolidating into atoms and molecules, let alone stars or planets or galaxies. But if the cosmological constant was any weaker, the universe would have almost immediately collapsed back in on itself following the creation event. And I call it the creation event because that's what it's referred to in the literature, by the way. How finely tuned does the cosmological constant need to be in order to avoid a catastrophic outcome mere milliseconds after the beginning of time and space? The cosmological constant has to be finely tuned to at least 1 part in 10 to the 122nd power. To put that number in perspective for you, there are only 10 to the 70th power atoms in the observable universe. But it gets better. Not only does the initial expansion of the Big Bang have to be exactly right, it needs to continue to be finely tuned throughout the entire history of the universe. The reason this poses a problem is because there are at least 4 other fields which are trying to counteract the effects of dark energy with varying degrees of strength, such as the electromagnetic field, the Higgs field associated with the weak nuclear force, and possibly the inflation or dilation fields hypothesized by inflationary cosmology and superstring theory, respectively. Throughout the universe's 14 billion-year-old history, the cosmological constant needs to be held in check by these other fields, which act as a counterbalance to dark energy, so that gas and debris can form planets and galaxies instead of just black holes and neutron stars. To put the degree of accuracy needed for the cosmological constant into perspective, again, I'll repeat that there are only 10 to the 70th power atoms in the observable universe. So the cosmological constant being finely tuned for our existence is still more unlikely, is still 10 to the 43rd times more unlikely than a blindfolded participant randomly picking a specific atom out of all of the atoms in the known universe. That's 1 in 1 quadrigintillion. That's a 1 with 123 zeros after it. That's how unlikely it is that our universe would come about by chance. Lawrence Krauss, now one of the 4 horsemen of New Atheism, also a physicist himself, wrote in 1998 that the existence of the cosmological constant, quote, would involve the most extreme fine-tuning problem known in physics, end quote. Notice that he calls it a fine-tuning problem. Physicist Florian Bauer, Juan Sola, and Hervoli Stefanikic, wrote that, quote, the cosmological constant problem is the biggest enigma of theoretical physics ever, end quote. This piece of evidence alone caused the famous Steven Weinberg to reluctantly begin searching for a many universes explanation for why we got lucky. And the majority of physicists who want to avoid the obvious conclusion of intelligent design followed suit. But wait, there's more. Don't worry, there's a lot more. Let's say by pure chance that the cosmological constant is exactly right. Still, the strong nuclear force has to be tuned exactly how it is, otherwise protons and neutrons would not bind together to create the elements on the periodic table that we see today. Michael Rees quotes a physical parameter that I don't even understand to measure the size difference between a proton and a neutron, and says that if it was off by a degree of just 4%, then the deuterium nuclei which forms helium would either be too strong, and there would not enough helium in the universe, but if it was 50% weaker, no heavier elements could be formed at all. Obviously, helium and the heavier elements are absolutely critical to advanced carbon-based life. Astrophysicist Sir Fred Hoyle was the first to notice that the helium which burns in stars coincidentally produces just the perfect amount and ratio of oxygen and carbon. Not only can this be attributed to the specific strength of the strong nuclear force, as previously discussed, but it also ties into the electromagnetic force. A group of researchers published their findings in 2000, claiming that, quote, if either of these forces were altered by even 0.5%, it would destroy nearly either all carbon or all oxygen in every star. This implies that irrespective of stellar evolution, the contribution of each star to the abundance of carbon or oxygen in the interstellar medium would be negligible. Therefore, for the above cases, the creation of carbon-based life in our universe would be strongly disfavored. End quote. The conclusion? The nuclear physical relationship between oxygen and carbon can't be altered even slightly. We have more. So you need 3 spatial dimensions, not 2 or 4, otherwise you could have no meaningful interaction between matter. You need gravity to be exactly as strong as it is, so stars and planets can form, but you also need the cosmological constant, otherwise everything would be one massive black hole. You need the strong nuclear force exactly how it is, so protons and neutrons can form and bind into nuclei. You also need the weak nuclear force, enabling hydrogen to burn in stars like our sun and produce oxygen and carbon. And you need the electromagnetic force to be exactly what it is, so that atoms and molecules can form. What else? Oh yeah, you need the ratio between matter and antimatter to be exactly what it is. That's a really interesting one, actually, because scientists have no idea why there isn't the same amount of matter to antimatter. All of our theories so far predict that we should have the same amount of each, with them annihilating each other upon creation. It turns out that we actually need slightly more matter to antimatter, and we know of the processes which produce slightly more matter, but according to Peter Bussey, there is no real understanding of how the universe should have turned out the way that it has. One thing that does appear to be necessary is the presence of at least 3 families of elementary particles to provide enough mathematical flexibility in the equations to generate the possibility of matter-antimatter asymmetry. End quote. This is a cool one. The density of energy to matter ratio, denoted by the Greek omega, must be within the numerical range of 0.9 to 1.1, if life-giving planets are to form. After the first second of the Big Bang, the ratio has to be exactly 1:1, with a precise range of 1 part in 10 to the 15th power. To quote physicist Peter Bussey again, quote, this means that space must not be appreciably curved, the universe must be geometrically close to being flat, to an extraordinarily high level of precision. In principle, there is no reason why this should be. The best theoretical reason to offer is that a process called cosmic inflation took place during the earliest fraction of a second after the Big Bang. This involves a sudden dramatic expansion of the universe by reason of the behavior of quantum fields that were originally present, according to this theory, and it would produce a very flat universe after the expansion stopped, almost irrespectively of what the curvature might have been before the inflation started. End quote. Imagine cutting a 2x4, and you need it to be 1 inch. Now, imagine if it can't be 1 inch plus or minus 0.00000000000000001 inches. Otherwise, the universe is destroyed immediately upon creation. Now, that is precision. And I'll tell you what, if you can pull that off, you're a darn good engineer or construction worker. And it turns out that God is both. But I'm not going to get ahead of myself. Let's do one more. The Oxford physicist Roger Penrose once calculated that the odds of the unique low-entropy condition of the universe arising out of pure coincidence is as small as 1 part in 10 to the 10th power to the 123rd power. He commented that, quote, "I cannot even recall seeing anything else in physics whose accuracy is known to approach, even remotely, a figure like 1 part in 10 to the 10th power to the 123rd power." End quote. Remember, there are only 10 to the 21st power stars in the universe, which is 1 billion trillion stars in the observable universe. Now, if you think that's an impressive number, all of the stars in the known universe, right? That's 10 to the 21st power. Now, how about 10 to the 10th power to the 123rd power, just to get the right amount of energy in the universe? That's an unfathomable number. That's literally a number that there's no such thing as a comparison that I could try to offer to you. So yeah, I could go on like this for a very long time. Astrophysicist Luke Barnes lists 10 constants in physics, which if any one of the values were off by even the smallest fraction, the universe would be impossible. And don't think impossible like perhaps some other kind of life might be able to form. No, we're talking like, oops, now there's no such thing as chemistry, or bummer, I hope you didn't need heat or energy in your universe. The source that I got this from was actually quoted back in 2016, so there might be more than 10 fundamental constants now. Remember that the trend is to continually discover more and more factors for fine-tuning, because the universe is continually discovered to be more and more complicated than we previously assumed, with the chances of life arriving by chance becoming smaller and smaller as our data improves. Even if you granted those 10 fundamental constants that created a universe with the same laws of physics that we have today, astrophysicist Hugh Ross estimates 140 more factors for life to be possible in the universe, ranging from the speed of light, to the initial uniformity of cosmic radiation, to the polarity of the water molecule. He cites 402 more finely tuned factors required if you want intelligent life, something bigger than a single-celled organism, perhaps, and 922 more independent characteristics for a galaxy and planetary system to harbor advanced life, as well as a vibrant ecosystem and things that we see here on Earth. I highly encourage you to go check out the sources for those dials of fine-tuning, along with their references to credible sources. You can find that online for free at reasons.org/fine-tuning. The degree of fine-tuning for these constants and quantities is beyond human comprehension. And it's important to note that, while the critics of fine-tuning are few and far between, not every physicist is on board with the fine-tuning of the universe. Victor Stenger, Steven Weinberg, and Alan Guth are all notable critics of anthropic fine-tuning. They point out, and rightly so, that it is possible that modifying factor B may compensate for your modification of factor A, and things of that sort. The relationships between these constants or factors can be difficult to discern in theoretical physics, and it's possible that further understanding could lead to eliminating previously thought independent variables. Putting hard and fast numbers on these things can be really difficult when we're dealing with theoretical physics. But the trend is not going in the direction that's friendly for the doubters of fine-tuning. More research continually unlocks more and more independent variables, which require fine-tuning, and more factors which need to be acutely precise for advanced life to be possible. These accomplished skeptics remind us that it is possible for a deeper understanding to reverse the conclusion the evidence is drawing, but so far, the evidence for fine-tuning is as airtight as Einstein's equations in the first place. Also, there is occasional controversy about some constants which require fine-tuning. But when there is controversy, it is usually centered around the degree of fine-tuning needed and the consequences of minute adjustments, not wholesale dismissals of the factors being finely tuned. In response to this skepticism, physicists such as Robin Collins, John Leslie, and Luke Barnes have seriously taken these critics and skeptics to task. After doing the research that I could, I hesitate to say that there is a consensus, since that is such a strong word among those who are familiar with scientific literature. But it does appear that the vast majority of cosmologists and astrophysicists agree that the universe appears finely tuned for life. I can also say with confidence that this is nothing like a partisan or polarizing issue in the field. Most cosmologists and physicists who are directly opposed to the idea of fine-tuning are not attacking the evidence of fine-tuning. They are churning out theories to explain why the universe is finely tuned. That's really important. Among the people who don't like the evidence, they are not questioning the evidence. They're just trying to find a different explanation for the evidence, with the sole exception of a few physicists that I already mentioned. So what I'm trying to say is that most people, for sure, recognize that this is concrete evidence, concrete research, concrete everything else, and they're not questioning it. There's only a handful who really would like to take a swing at some of this evidence and say, well, maybe you don't know this and you don't know that. But that's really the basis of their argument, is they're saying, look, it's possible that further evidence says that if you manipulate this, it will actually have this unintended side effect that we could not have foreseen, and that sort of a thing. And it is no question at all that the burden of proof lies on the skeptics to demonstrate that the universe is not finely tuned in the wake of such overwhelming and seemingly insurmountable evidence. John Leslie points out that even if skeptics wish to pick apart and quibble about certain variables, the sheer quantity of them and their unquestionable significance for advanced life should form a powerful cumulative case for the fine-tuning of the universe. That's also not to mention the credibility and weight of the physicists who originally published this stuff previously mentioned. Their work is not dismissed so easily, and there are only a handful who even try. The rest are working away trying to find multiverse theories in order to explain how our universe got lucky. Okay, end rant. So, how have physicists and cosmologists responded to this tidal wave of evidence, which has been accumulating since the 80s, but has certainly exploded since the mid-2000s? I have some quotes that should give you a taste. Physicist Freeman Dyson has said, quote, "I do not feel like an alien in this universe. The more I examine the universe and study the details of its architecture, the more evidence I find that the universe, in some sense, must have known that we were coming," end quote. Paul Davies, previously mentioned to be an atheist, has since stopped promoting atheism, conceding that, quote, "the laws of physics seem themselves to be the product of exceedingly ingenious design," end quote. He further commented that, quote, "there is for me powerful evidence that there is something going on behind it all. The impression of design is overwhelming," end quote. Then again, in another place, quote, "it seems as though somebody has fine-tuned nature's numbers to make the universe," end quote. Arno Penzias, who shared the Nobel Prize for Physics for the discovery of the cosmic background radiation, remarked, quote, "Astronomy leads us to a unique event, a universe which has created out of nothing, one with the very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say supernatural, plan," end quote. George Ellis, a colleague of Stephen Hawking and Roger Penrose, has said, quote, "amazing fine-tuning occurs in the laws that make this complexity possible. Realization of the complexity of what is accomplished makes it very difficult not to use the word miraculous without taking a stand as to the ontological status of that word," end quote. Stephen Hawking, obviously a well-known atheist, said in his book, A Brief History of Time, quote, "it should be very difficult to explain why the universe should have begun in just this way, except as the act of a God who intended to create beings like us," end quote. Cosmologist Edward Harrison concluded this, quote, "here is the cosmological proof of the existence of God. The design argument of Paley, updated and refurbished. The fine-tuning of the universe provides prima facie evidence of deistic design. Take your choice. Blind chance that requires multitudes of universes, or design that requires only one. Many scientists, when they admit their views, incline towards the teleological or design argument," end quote. Robert Friffiths, who won the Danny Heinemann Prize for Mathematical Physics, observed, quote, "if we need an atheist for a debate, I go to the philosophy department. The physics department isn't much use," end quote. Thank you for listening to the Well-Read Christian Podcast. Next episode, we're going to talk about how different thinkers respond to the fine-tuning of the universe. Some are going to opt for multiverse theories. Some are going to opt for simulation theories. Anything to avoid the obvious conclusion that it appears the universe was designed with purpose by an intelligent cause. Thank you so much for listening and supporting, and I hope to see you next episode.